Alright, we're in section R.8, and we're going to start talking about an awesome thing, which are radicals. Okay, radicals, square roots, cube roots, etc. So let's get some property. The first one. If I have the nth root, so any root of a product A times B, I can break it up into the nth root of A times the nth root of B. 2. Same thing with division. If I have the nth root of a quotient, so A over B, I can break it up and I can do the nth root of A over the nth root of B. And third, if I have the nth root of something to an exponent, it doesn't matter what order I do it in. I can do the exponent first and then the nth root, or vice versa. I could do the nth root of A and then do the exponent. The order makes no difference as long as you do both. So let's look at how we're going to use these. Okay, let's try to simplify some radicals. So let's start with an easy one first. So I have the square root of 25. So here it's understood that if there's no number written, you can always put a 2 there. So this is the square root of 25, but it's just common that normally that means square root, so we just always remember it. So the square root of 25 is 5 cents. If I take 5 times 5, I get 25. Back to the inside. This is example 1. Let's look at another one. Let's say I have the cubed root of 8. Well, here this is cubed root. So I have to think, okay, what multiplied by itself 3 times gets you back to the inside? And the answer is 2 cents. 2 times 2 times 2, 3 2s is 8. Okay, so far so good. Let's look at a couple more. Okay, example 3. Let's try this. Square root of minus 16. This is a tricky one. Well, this is not equal to 4, since 4 times 4 is 16, which is not minus 16, and it's not equal to minus 4, since minus 4 times by minus 4 is, again, 16, which is not minus 16. So here this is what's called not a real number. And we've learned something, which is we can have no negatives in even roots. Even roots. The odds, I think we can do it. So let's take a look. Okay, example 4. Let's say I have the cubed root of minus 27. Well, that's going to be equal to minus 3. Since if I take minus 3 times itself 3 times, this is going to give me 9 times by the minus 3, which gives me that minus 27. So in odd roots you can do it because you get that odd one that'll turn the whole thing negative. But evens you're in trouble, so no negatives in even roots. Okay, now back to the properties. So let's look at, let's say I wanted to simplify this. I have square root of 32. Okay, all the ones we've looked at so far have been perfect squares, perfect cubes. But here 32, that's not a perfect square. So the key is to look at, focus on the root. So always be careful about it. Look at what kind of root you have. That's going to tell you how to make how your brain should think. So here, square roots. I'm going to use that property where I need to find a square root. So what's the biggest square root that's inside 32? Well, I can rewrite this as 16 times 2, and then I can use that property. Square root of 16 times by the square root of 2, and this gives me 4 root 2, and this guy is simplified. Okay, things to notice here. This 2 is trapped. It's trapped inside the root, and the square root of 16, that's a perfect square that turns out to be a 4, not root 4. This simplifies completely to the 4, and we got it. So the square root of 32 can be simplified to 4 times root 2, and that's going to be very useful to us in the next video. So let's try another example. Okay, let's try to simplify this. I got cubed root of 16. So be careful, this is not equal to 4 because I have a cubed root here, not a square root. So I gotta make my brain think about perfect cubes instead of perfect squares. So you should get familiar with like basic cubes. So 2 cubed is 8, that's a good one to know. 3 cubed is 27, that's a good one. 4 cubed is 64. 5 cubed is 125. These are all the ones you should look for. Alright, let's see. Back to this problem. Do I have any perfect cubes in 16? Yeah, you betcha. Cubed root. I can rewrite 16 as 8 times 2. Then I can use the property. So this is the cubed root of 8 times by the cubed root of 2. This is a perfect cube, and I get 2 cubed root of 2. That 2 is big out front, that's your coefficient, and you have to continue to write that 3. Otherwise, you change a cube root into a square root, which is impossible. This is our nice simplified answer. So remember, with cube roots, look for those numbers, not perfect squares. Alright, let's look at one more. 2 more, probably. Alright, let's try to simplify this. I've got square root of 50x cubed. Okay, so square root, and let's see, I'm looking for perfect squares. So the number, no big deal. So 50, is there a perfect square in 50? Yes. It's 25 times 2. We're going to do the same thing with the x's. We're going to split up the perfect squares and leftover stuff. So I can rewrite x cubed as x squared, there's my perfect square, times by an x. And now I can use that property. So the square root of 25 is a 5. That takes care of that. That 2 is trapped. The square root of x squared, those guys cancel out. That gives me an x. And then what's left inside? I got a 2x. And we got it. Okay, and that's how we use the properties. And that'll do it for this one.